Okay, let's have a look at electrolysis. So the assessment statements are here, okay? So we're gonna draw the essential components of an electrolytic cell. We're gonna state that oxidation occurs at the positive electrode and reduction occurs at the negative electrode. We're gonna describe how current is conducted, and we're gonna deduce the products of electrolysis of a molten salt. Okay, so why don't we start by talking about ions. So group 1 elements make 1 plus ions. So examples are sodium, Na plus, lithium, Li plus, K, K plus. Okay, and group 7 elements make 1 negative ion. So the ones that you're going to see are Cl negative, Br negative, and I negative. Now the second point here is that group 7 elements are diatomic. So they exist as pairs of atoms joined together. Cl2, Br2, and I2. So if you're writing a half equation, you have to remember that the Cl negative, there's 2 of them, right? Because we're going to make chlorine gas on the right side. Okay? And of course, this is oxidation because we're losing electrons. So be careful with your ions. Right, let's look at the components. So we have the anode here and the cathode there on the right, positive and negative. Okay, don't confuse this with a voltaic cell. On a voltaic cell, the anode is negative. With an electrolytic cell, it's positive. Okay, with the electrolytic cell, the cathode is negative. Okay, now an ox and red cat is the same. Okay, so oxidation is at the anode, reductions at the cathode. Okay, don't forget that. Now this thing at the top here, that's a battery. So you must draw in the battery. Okay. So there's the components. Now one thing that students often leave out is a line like this to show that there is a solution in the container. Okay, and that solution is called the electrolyte. Okay, so an electrolyte is a solution that conducts electricity. So the electrolyte here is the molten salt. Okay, so molten means melted. Okay, and that's the electrolyte. Okay, how is current conducted? Well, first point, the battery pushes electrons to the negative electrode. Second, the current is passed through the electrolyte by the ions. Okay, so you have to know these. Okay, make sure you know these two ways in which current is conducted. Right, let's look at an example. Electrolysis of molten sodium chloride, which is NaCl. So the ions that we have are Na plus and Cl negative. Okay, so I'm going to quickly draw in my components. Got positive and negative, anode, cathode. Okay, don't forget your line going across, which shows that there is some solution in there, some electrolyte. Now in here we're going to have the ions Na plus and Cl negative. The Na plus is attracted to the cathode, the Cl negative is attracted to the anode. Okay, now what's going to happen is when this Cl negative gets to here, it's going to give up an electron, and that electron is going to flow from the anode to the cathode, just like in a voltaic cell. Okay, it goes from anode to cathode. So we can write half equations. So we've got 2 Cl negative. Don't forget it's a 2 Cl negative. Everything's in liquid, and it's going to give you Cl2, which is a gas, plus 2 the negative. Now the sodium is positively charged, so it's attracted to the cathode, where it's going to gain an electron and be reduced. Okay, so we've got a redox reaction, and we're going to make NaL. Now, of course, it's not balanced for electrons, so we can put a 2 there, a 2 there, and a 2 there. Cross out the electrons, and that's your balanced equation there. Okay? And the ratio of Na to Cl2, well, there's 2 moles of Na to 1 mole of chlorine gas. Okay, let's look at one more example. Electrolysis of molten potassium bromide, which is KBr. Okay, so let's complete the diagram. Let's label the electrodes, anode, cathode. Let's draw a line to show we have something in there, some electrolyte. Now what ions are we going to have? Well, we're going to have K plus and Br negative. Okay, so just like before, the K plus is going to go to the cathode and the Br negative to the anode. Okay, and if we write half equations, it's going to be 2 Br negative, and that's going to give us bromine. Now don't forget, bromine is Br2. Okay, and we've got 2E negative. Okay, and for the potassium, K plus, it's going to be K plus, and it's going to be reduced. This is reduction, isn't it? And we're going to get potassium metal, but it's still a liquid. So we've got reduction and oxidation. Okay, and we have to balance this for electrons, and again, they can cancel out there. Okay, and again, the ratio of K to Br2 is 2 to 1. And the last thing we have to show is electron flow. And the electron flow is going from the anode to the cathode. And that's it.